You look outside your window and are surprised by the amount of stars twinkling. You wonder, where are they? But more importantly, how did they get there? Luckily, we'll answer all those questions. The life cycle of a star is a natural process that begins with its birth and, like any living thing, ends with its death. The life cycle of a star can be classified into 7 stages. Let's take a look at each one in depth. Number 1. Giant gas cloud. A star begins its life as a giant gas cloud, which is a collection of gas and dust particles that are pulled together by gravity. These clouds can be massive, with some containing enough material to form thousands of stars. As time passes, the gas cloud began to collapse under its own gravity. The temperature and pressure at the center of the cloud increase, causing it to become denser and hotter. The cloud is now in the process of forming a star. The gas cloud begins to fragment, breaking up into smaller pieces, forming a cascade of fragments. Many of these fragments would eventually give birth to a star. The process of fragmentation is essential in the formation of the biggest stars. The fragments that are produced are the building blocks of the stars, and they continue to grow and merge until they form a protostar. One of these fragments, in particular, caught the attention of the universe. It grew and merged with other fragments. Slowly, but surely, as it continued to gather mass, it became hotter and brighter. This fragment was on its way to become a star, a celestial entity that would illuminate the darkness of space. This young, growing star was known as a protostar. It was not yet hot enough to undergo nuclear fusion, the process that fuels the stars. But deep within its core, immense pressure and temperature were building, like a fire waiting to be ignited. The protostar was a cosmic furnace, ready to unleash its brilliance upon the universe. As the protostar continued to grow, it gathered mass and heat. It reached a critical point. The temperature at its core soared to about 10 million degrees Celsius, and nuclear fusion finally ignited. The protostar burst into life, shining brightly with energy generated by the fusion of hydrogen atoms into helium. Number 3. Main sequence star. The protostar had now transformed into a main sequence star, the stage where it would spend the majority of its life. It radiated heat and light, illuminating the cosmos and shaping the destiny of its surroundings. The main sequence stage was a period of stability, where the outward force of fusion reactions balanced with the inward pull of gravity. The star neither lost nor gained matter, existing in a delicate equilibrium. Nuclear reactions at the core of the protostar provide energy that makes it shine brightly. This stage is called the main sequence, and the exact lifetime of a star depends on its size. Very massive stars use their fuel up quickly and may only last a few 100,000 years, while smaller stars use up fuel more slowly and can shine for several billion years. The main sequence stage of a star's life is the longest and most stable period. During this stage, the star fuses hydrogen atoms into helium atoms at its core, releasing energy in the process. The exact lifespan of a star depends on its size. Very massive stars use up their fuel quickly, and may only last a few 100,000 years, while smaller stars use up fuel more slowly and can shine for several billion years. As the star continues to fuse hydrogen into helium, the core of the star begins to shrink and heat up. This causes the outer layers of the star to expand and cool, causing the star to become a red giant. The red giant phase is the next stage in the life cycle of a star, and it marks the beginning of the end for the star. Number 4. Red giant. Eventually, the hydrogen that powers the nuclear fusion inside a star begins to run out. The star then enters the final stage of its lifetime, the red giant. During this phase, the temperature drops, causing it to change color from yellow to red. The red giant is a short-lived stage in a star's life cycle, lasting only a few million years. Eventually, the star will run out of fuel and will no longer be able to fuse elements in its core. The star then will enter the final phases of its lifetime, which depends on how massive the star is. A massive star will undergo a supernova explosion, while a smaller star may gradually cool and will shrink to become a white dwarf. Number 5. Supernova. But for some stars, the red giant was just the beginning of a spectacular and violent end. These stars were so massive that they would undergo a supernova explosion, a cosmic event that would outshine the entire galaxies. During a supernova explosion, the star's core collapses under the force of gravity, causing a massive release of energy. The outer layers of the star are blown away at incredible speeds, creating a shockwave that travels through space. The explosion is so powerful that it can briefly outshine an entire galaxy. The remnant of the explosion can take on one of two forms, depending on how massive the star is. If the star is 1.4 to about 3 times as massive as our Sun, it will become a neutron star. A neutron star is an incredibly dense object, with a mass similar to that of the Sun, but a size similar to that of a city. Neutron stars are incredibly hot, with surface temperatures of over 1,000,000 degrees Celsius. If the remnant is more massive than that, it will become a black hole. A black hole is a region of space where the gravitational pull is so strong that nothing, not even light, can escape. Black holes are invisible, but their presence can be detected by their effect on nearby matter. The supernova explosion is a spectacular and violent end to the life of a massive star, but it also is beginning, as the materials from the inside of the star are scattered across space. This material can collect in the nebulae and form the next generation of stars, continuing the cycle of creation and destruction that shapes the cosmos. Number 6. White dwarf. A smaller star, like the Sun, will gradually cool and shrink to become a white dwarf. A white dwarf is a small, dense star that is about the size of Earth, but has a mass that's similar to of the Sun. During this phase, the star's outer layers are ejected into space, forming a planetary nebula. A white dwarf is a small, dense object that is the final stage of evolution for low to medium mass stars, including our Sun. It is the stellar core left behind after a dying star has exhausted its nuclear fuel and expelled its outer layers to form a planetary nebula. White dwarfs no longer support nuclear fusion reactions that generate energy, but they are still extremely hot. They cool over time, and it is predicted that they would ultimately form black dwarfs. Although the universe is not old enough yet for any black dwarfs to form, white dwarfs are very dense, with a mass comparable to the Sun, while their volume is comparable to Earth. They are difficult to find because of their small size, and no white dwarfs can be seen with the unaided eye. The light they generate comes from the slow, steady release of incredible amounts of energy stored up during billions of years by a star's nuclear powerhouse. By the way, make sure to subscribe if you want more videos like these. Number 7. Black dwarf. But what happens when a white dwarf cools down completely? The answer is a black dwarf. A black dwarf is a hypothetical object that is the end result of a white dwarf that is cooled down to the point that it no longer emits any light or heat. It is a cold, dark, and lifeless object floating silently through the cosmos. The concept of a black dwarf is purely theoretical, as the universe is not yet old enough for any white dwarfs to have cooled completely. But the idea of a black dwarf serves as a reminder of the ever-changing nature of the universe and the incredible forces at play within it. In conclusion, the life cycle of a star is a fascinating process that takes billions of years to complete. It all starts with a giant gas cloud, which eventually collapses to form a protostar. The protostar then becomes a main sequence star, which can shine for billions of years. As the star runs out of fuel, it will expand and become a red giant, and eventually, it will either become a neutron star, a black hole, or a white dwarf. The life cycle of a star is determined by its mass, and the larger its mass, the shorter its life cycle. Thanks for watching, and see you in the next video.